Last video we looked at how you can build a TensorFlow input data pipeline using tf.data.Dataset class. In this video we will look into how you can optimize the performance of that input pipeline using prefetch and caching. We'll just go over some theory first and then we'll write code. Alright, so let's get started. What we discussed in the last video was this. Usually when you have small images, you load those images into RAM from your hard disk in NumPy array pandas data frame and you can train your model easily. But when you have let's say 10 million images, when your data set is so big, your computer might give you an expression like this: too much data, I can't handle it. Therefore, the tf.data.Dataset is quite useful because it can load this data into batches and then train the model on those batches one by one. Okay, so my batch 1, batch 2, and so on. Now, if you look at the same exact picture in a CPU GPU kind of time view, where GPUs are mainly used for the training. So when you're doing forward pass, backward pass, doing all those matrix manipulations, those are happening on your GPU. So let's say my loading first batch is the reading from disk is being done by CPU. So CPU is reading all these images into my memory. It takes let's say 3 seconds. Then it gives those images to GPU for the training. And this is batch 1. Similarly, batch 2 takes same time. And if I plot a time view of this whole operation, you will get a graph like this. Here the first, it took 3 seconds to read batch first. During that time, GPU was sitting idle, by the way. It was not doing anything. Then it took 2 seconds to train it. Then you read second batch. So CPU is reading the second batch and it takes 3 seconds. Overall, let's say if there are 3 batches, it will take 15 seconds. But we can optimize the performance of our data pipeline by doing this. So assume that GPU is processing your batch 1, and during that time, what about CPU reads batch 2? So both of these units are working in parallel. When GPU is training my batch 2, CPU is preparing the next batch ready. So every iteration, my CPU is keeping the next batch ready, okay? And this approach will take you overall, I think 11 seconds. So just compare 11 seconds versus 15 seconds. So you've just saved time in your training. This can be done by prefetch API. So all you have to do is here tf.data.Dataset.prefetch 1. 1 means how many batches I want to prefetch. So when I say 1, when the GPU is training my batch 1, it will pull one extra batch in the memory. If I say prefetch 2, it will, at this point, it will prefetch batch 2 and batch 3. Okay. Normally you will supply AUTOTUNE argument, so you will let the TensorFlow framework decide for itself how many batches it wants to load in advance. Okay, so you will see people using AUTOTUNE very often. And if you look at the whole pipeline, and this is what we looked into in our last video as well. So if you have not seen last video, I highly suggest you guys all watch that last video. So here you will see that majority of the TensorFlow code bases, you will see prefetch being used at the very end. So you are forming your complete pipeline. You're saying map, filter, map, whatever. And in the end, you will do prefetch so that both GPU and CPU can work in parallel. You want to make optimal use of your hardware resources, and prefetch allows you to do this. Now we are talking about this map operation. So just think about this. You're reading all these images. You are converting them into NumPy array. Then you are doing filtering. You are doing mapping. You are doing so much processing, okay? And when you are running deep learning training for multiple epochs, you are doing the same operation multiple times. So remember, one epoch means, let's say if I have 10 million images, I will go through all 10 million images and perform the training. That is one epoch. The second epoch, I will repeat the same thing. I will again go over those 10 million images and I will be doing all these operations, map, filter, map. So do you see some redundancy here? You're reading the same files and then mapping and filtering again. So this issue can be addressed by cache function. So this is a pictorial representation of, if you're not using any caching, what will happen is you will see here x-axis is the time, okay? So you are spending some time opening the file, some time reading it, then mapping, filtering, all doing all this transformation, then you're training. Again, you are reading it, mapping, again training. Okay, so up till now, up till this vertical arrow is good. But then when the second epoch starts, again you are opening the same set of files. So let's say you are training some kind of text model where you're opening one single file which is huge, which has, let's say, 10 million lines in it. Then you have to open the file, then you are reading the file in chunks. So let's say you read first 10,000 lines, then you do mapping, you do some transformation, then you do training, then again you read next set of 10,000 lines, and so on. And when the first epoch is over, in the second epoch, you again open the same file, same 10 million line file. Then you take, this one is a 10,000 line chunk. Then you do all the transformation, training, again, next set of 10,000 lines, and so on. So you see some redundancy. So these operations, open, read, map, are redundant. Now this is okay if you have a memory problem, but let's say if you can fit something into memory, then you can use a cache operation. And what you can do is, now watch carefully, okay? Now you have this image in your brain. Now look at this particular image. You see, so when I do tf.data.Dataset.cache, what it is going to do is, it will do all this open, read, map in first epoch, but for the second epoch, see, this is the second epoch, okay? This one. It will just train the model. So you are saving your time in opening and reading the file. All right, let's get into coding now. Here is the TensorFlow official documentation where they have explained how you can get better performance by using prefetch, cache, etc. And in this example, they have created this artificial dummy data set where you can mimic the latencies in opening the files, reading the files, etc. So we're going to use the same example here. And I have a Jupyter notebook here, and here the TensorFlow version is 2.5.0, which is the latest as of this recording. So make sure you have a latest version, because some older versions have backward incompatible APIs. Now, I have modified this example a little bit just to make it a little simple. So what we do is, we are going to create a class with our tf.data.Dataset as a base class. Okay, so when you supply this as in the argument, it will derive this file dataset class from this dataset tf.data.Dataset. And again, to remind you, what we are doing here is we are measuring the performance using prefetch. We will see how using prefetch you can optimize the use of CPU and GPU, and you can get a better training performance. And to mimic the real life, latencies in reading files or reading objects from the storage, we are creating this dummy class. Okay, so the purpose of this dummy class is to mimic the real world scenario. Let's say you are reading files from the disk. Okay, and I will say, okay, reading files in batches, and here you supply a number of samples that you want to read. So when you read the file, first thing is open file. Okay, so let's say open file is taking some time. So I'm just putting dummy time.slip just to mimic the delay in opening the file. Then you start reading, let's say, few lines chunk by chunk. So let's say you have million lines in your file, you want to read first 10,000 lines and so on. So I will say for sample index in range, okay, sample index in range number of samples. So I have total, let's say 3 samples. I'm just reading, let's say I'm reading each line one by one. And the delay to read each line is, let's say, this much, 0.015 second. And you are returning that particular sample index here. Again, this is a dummy class, okay? In real life, you will be reading the file, you will be returning each line. So here, since I'm interested only in measuring performance and not the actual content, I'm just saying yield something. And yield is a generator. So if you're not aware about generator in Python, go check out my generator video. So in YouTube, you can do code basics, Python generator. You'll get a fairly good understanding of what generator is. Then we'll override new method. So what this new method will do is this. So let me just show you. New call. Okay. So whenever you create an object of this file dataset, new takes one positional argument. Okay. Here you have to supply the class. See, new call. So whenever you create an object of this class, this particular new method is called. Okay. And in this one, what I want to do is I want to do this tf.data.Dataset dot from generator. So in dataset, there is a method called from generator where you can say, okay, class dot. So this class is the class reference and that has this method. So this is your generator and you will say output signature is, the output signature is like, what does it return? Well, it returns an integer. So tuple of integer comma nothing. So see tuple. So tensor specification, you will say integer 64. That's what it returns. And the third argument is args is equal to number of samples. So this is the argument, number of samples you supply into this function. Okay. So don't worry about this too much if it looks complex. As we move ahead in the code, you will understand it better. Okay. Now, what happens is, typically when you have a training function, okay, let's say whenever you have a training function, you will have a data set and you will have number of epochs. Let's say number of epochs is 2 default. Okay. So in usual training loop, what you do is for epoch num in number of epochs, you go through each epoch and you will go through each sample in a data set. Okay. And you will perform a training. So let's say the training performance is 0.01. So this training performance, this dot sleep, okay, is basically, let me show you here, is basically this time, this yellow time slot. Okay. And this particular time, which is reading the file lines, is this. And this diagram doesn't have this particular time, but if you want to look at this time to read the file, it is in the other diagram, which is this. See this blue time slot. Okay. So I hope that part is clear. So now you're training, and I'm just introducing an artificial delay here. So here I will just call this function benchmark actually, because we are benchmarking everything. Okay. And now what is this data set? Okay. So the data set is an object. So when I do this, it creates an object of this dataset class, file dataset class, and I want to benchmark this. Okay. And the way you benchmark it is by putting this time it line magic, cell magic. Okay. All right, let's see. Number of samples is not defined. So where is it not defined? Let's see. Where is my number of samples? I think it's complaining about this particular class not having this particular method not having that argument. So by default, let's say number of sample is 3. So I fix that value here. Okay, getting another error. Values must be a signature. Okay, I need to return this actually. Because when you do new, you're returning a class. Still getting an error. Okay, values must be a signature. What is it? Okay, here I need to pass a tuple. So maybe that's the problem. Let's see. No, integer object is not iterable. For epoch number is number in number of epochs. So number of epochs, it has to be a range actually. Getting so many errors today. All right, it's gonna work this time. Amazing. So now it's benchmarking the performance of file dataset as is. And let's say this is 321 seconds. So what just happened is this. So you read those files in batches. So while CPU was reading, your GPU was training. So you read everything sequentially. So the performance was not that great. Okay. Now you're going to use this prefetch API and we'll see how that improves the performance. So I'll just copy paste the same thing here and just append this with prefetch. And prefetch, I'll say prefetch one batch or one sample. Now why I can call free prefetch? Because file dataset is derived from tf.data.Dataset and this has that prefetch method. Hence I can call it from a child class as well. And when you measure the performance, you see the improvement 253 milliseconds. You see close to 70 millisecond difference you see here. And if you run it for more epochs, you will see more difference. And the popular argument to prefetch is AUTOTUNE. So people usually supply AUTOTUNE argument. Actually, it's tf.data.AutoTune. Okay, and that will give you around like similar performance. But this AUTOTUNE will figure out on its own how many batches it want to prefetch while your GPU is training. Okay, so I hope this is clear. If you have any questions, please post in a video comment below. But the idea is very, very simple. We are just implementing this particular diagram that you're seeing here. So previously, like in this line, the operations were happening in this order, step by step. So CPU and GPU was not utilized to its optimal level. But then by doing prefetch while GPU is training, you are using CPU to prefetch your previous batch. And since we have these artificial delays introduced here, you can kind of compare the performance of two APIs. If you prefetch, let's say 2 or 3 samples, performance is not gonna change that much. Okay, but majority of the time people use this AUTOTUNE. So in our future deep learning tutorials, you will see us using prefetch a lot. Okay, now let's talk about the cache API. Okay, so cache. All right, what is cache? So let's read the documentation. So if you read the documentation of cache API, caching here. So here I'm reading some documentation of for cache API. So cache, what it will do is, I think we covered this in presentation as well, where if you're reading the file and opening it and mapping it, and if you're running it across multiple epochs, see for the second epoch, you don't need to do all this operation. So when you do dot cache, you don't see this blue and purple blocks here. So you're saving all that time. So here we are just going to use official TensorFlow documentation and we'll implement that. So let's say you are creating a new data set here. Okay. And the data set is nothing but just a bunch of numbers. And then let me do for d in dataset. Okay, print d dot numpy. See 0 to 4 number. And now let's say I want to compute the square of that. So how do you do that? You can do map and you can do lambda x and return me x square, correct? And that is my data set. And again, if you print this, we have covered all this in previous video, so should be pretty straightforward. You're just transforming it and you are just computing a square of each of these numbers. Now, if you do cache, see, if I'm running multiple epochs on this data set, then it will have to do this mapping multiple times. But if I just do cache, so if I do dataset is equal to dataset.cache, if I just do that, and now when I iterate through that, so see, you can iterate through this dataset using this particular iterator. See, you can do this. Okay, I think you might know about this. So if you do this, let me just quickly show you. So when you're doing this, and the other way of doing the same thing would be if you just put it in a list, you can do it same thing in a one line. So now when you do cache, it is reading this data from that cache. So when I do it, execute it a second time, it is reading it from cache, you know. So it is not executing this map function again. If you had not put this in cache, then every time you do this, it will be computing this map function again. So that's the benefit. Now let's apply this map function to our original file data set. This guy here. Okay, so first I'm going to create some dummy map function. So I will create dummy map function again with some type of delay. So time delay is, let's say, time.sleep 0.03. Now, if you're using this in a TensorFlow map API, see, eventually my goal is to use this in, I want to create an object of file dataset, and then I want to use this map, this map function. But when you pass this here, what happens is, see, let me run it. You get some error because this function needs some special processing. So you need to wrap this in tf.py function and say lambda x, or lambda, even if you don't supply, it's okay. So you're supplying, you are saying, okay, this is the sleep, and then these are the arguments, okay, and then you are returning that as, so same string as it is. So the whole purpose is basically, if you don't want to worry too much about it, it's introducing some kind of delay. Okay, so when you do this, see, now this is working. Now we will benchmark this function. We'll benchmark it. Let's say run this for 5 epochs. Okay, and I want to time it. So this will measure the time of this particular cell, the whole cell. And minus n1 minus r1 is just run the one loop basically. Okay, so file dataset dot map. Let's see what is wrong here. Benchmark is not defined. Okay, I have a typo here. So 1.27 second, that's what you see here. And now we'll see how performance can be improved by using cache. So I'm copy pasting same code, okay, but after map I'm doing cache. And when you do that, see, it takes half time, because it's actually less than half time, because this cache, what would have done is, see, I'm running it for 5 epochs, right? So First epoch, okay, when I call map function, it will introduce a delay, but second time the data is cached. So second time onward, second, third, fourth, and fifth epoch, it is not calling this map function. It is using the map data from the cache itself. All right. So I hope this gave you some idea on prefetch and cache. Prefetch and cache is something we'll be using in our future videos for training TensorFlow models using tf.data.Dataset. If you need more information, I'm going to provide a link of all these awesome TensorFlow documentation pages. So go check out the video description, and also the link of this notebook is in video description. Please practice this code. Practice makes the man or woman perfect, friends. So you got to practice this. So whatever code we went through, just practice this, try to change all these parameters, try to get a sense or digest what you learned today. And if you like this video, please give it a thumbs up. Your single thumbs up is like a fees of this free class. Okay, so don't forget to give that, and share it with your friends. That's also important. All right, thank you very much for watching. Bye.